Hi, welcome back.
Gotcha.
Hi. Excitement.
No, thank you.
All right. So here's what we're working on today. In the past couple sessions together, we've done triangles, we've done similar shapes, and in those similar shapes, we've done a lot of proportions. We're going to still do proportions. We're not done with the proportions. But we're going to be working with something called the geometric mean. The geometric mean, well, let's talk about that word before we get too much more into it. Have you heard the word mean before?
Yes.
Mean.
What does it mean?
Something you find on the internet.
If you're talking about people, the word mean means not nice. But we're not talking about people, we're talking about numbers. And in numbers, the word mean means average.
Oh, means definition.
And if you're finding an average, typically what you've done is you've added up a bunch of numbers, right? And then you've divided by however many they are. Yay, you got the mean. The geometric mean is a slightly different formula. Here's your formula right here. We're going to say that x is the geometric mean. Okay? So the geometric mean x is equal to the square root of some number times another number. Okay? So this geometric mean formula only works with two numbers. Only works with two numbers. Okay? We're going to practice. We're going to come down here and we're going to practice. All right. Which one do you want to do first? I'm saving 4 and 9. We're not going to do those right now. We'll do those last. Let's do number 1. All right, let's do number 1. All right. Find the geometric mean between these pairs of numbers. All right. One of the numbers is going to be A from our formula, and the other number is going to be B from our formula. Okay, let's write down our formula. Our formula was x, the geometric mean, equals the square root of A times B. That little mark between them means multiply. It's a little star. All right, so now I'm going to substitute. What is the value for A?
4.
And what is the value for B?
4.
All right, and what is 4 times 4?
16.
And what is the square root of 16?
4.
You can use your calculators if you're not sure what that square root was. Easy enough? Okay, let's do another one where the numbers are getting a little bigger. Do you want to do number 2 or number 3? Number 4. We'll do number 4 in a bit. I know it looks scary because, oh my God, fraction. So I'm saving that one. Number 2? All right, number 2. One of the numbers is A, one of them is B. Okay, so we're going to write our formula. Please always start with your formulas. You'll be awarded up to 4 points for each of these questions when you're doing them on practice. 1 point for the formula. And then 1 point for substituting in properly. And then another point for multiplying. So 4 times 6 is 24, I heard. All right, now go to your calculators. Do the square root of 24. Wait, before you call out the number, those of you who have these calculators, who does not know how to pull up square root on this?
I don't know.
You're not sure how? Okay. I want to take a moment to make sure that we know how. Okay. So there's the number that the rest of you are trying to find. Okay, so what we're going to do is you're going to hit the control button, and then you're going to find the x squared button. You see the little square root above it in orange? Okay, so you're going to click that, and so now you have square root, and it's open, and then you're going to put the number you want to take the square root of, and then hit enter, and it's going to give you a number. All right. Let's round this to, let's see, 1 decimal place. Okay, so 1 decimal place, this becomes, I'm going to do a squiggly equals. Do a squiggly equals when you go from square root to decimal. And the decimal was 4.9.
How come 4.9 and not like
not
Okay.
4.8989, because we're rounding to one decimal place.
Oh, okay.
All right, great question, thank you.
Because somebody gets confused with
Yeah, I understand, I know. All right, saving 4 and 9, is there another one that you want to see with bigger numbers? Number 5? Okay, number 5. Same formula. The geometric mean is x equals the square root of some number times another number. Here are my numbers. One number is A, one number is B. I'm going to substitute. This is the square root of 12 times 20. 12 times 20 is, what was it? 240. And then the decimal for the square root of, now notice how I'm putting the squiggly equal. Squiggly equal means más o menos, right? Approximately equal to. Give me the decimal.
It's 15 point dang it.
Ah, he beat you to it, didn't he?
Dang it.
He was excited to say it.
Man, dude.
That's all right. It's okay.
Dang.
All right, let's do one of the ones with the fractions, right? We're feeling better with these? Okay, let's do number 4, because number 4 looks scary.
It's not a monster.
All right, we're going to do the same thing. Check it out. Okay, one of them is A, one of them is B. All right, we're going to use the same formula. And I'm going to color code. So there's my A. Multiply it. There's my B. All right, check this out. 1/2 times 2. In my calculator, I'm going to do Control Divide to bring up my fraction. I'm going to put 1 over 2. Whoops.
Get 1.
1 over 2. And then I'm going to push to the right until the cursor gets really big. That means that I'm outside of the fraction.
Get 1.
Times 2. And as he's saying, my answer is 1. So this is the square root of 1. What's the square root of 1?
1.
And we're done. All right, let's look at number 9 because, oh my God, now there's 2 fractions.
There's too many 1s.
There's so many fractions. The process is the same. One of these fractions is A. The other fraction is B.
Let me test it.
The geometric mean is equal to these 2 fractions multiplied together.
You get
Okay,
you get 1 over 8.
1 over 8 is what you get when you do that multiplication
Yes.
of fractions? Okay. And then when you take the square root of 1 over 8? 0.35? It sounds weird. I kind of believe you. I kind of don't. Well, mostly because I haven't typed it in myself.
You're a bad person.
Okay. I'm sorry. You confirmed it?
Yes.
Yes. It's 0 point something?
Yes, it's 0.35.
Ah, okay. I totally believe you now. Okay, but we're doing 1 decimal place, yes? So 0.4. Okay. Thank you. Thank you for the confirmation. I also confirmed it myself. This is why I don't like having my calculator up there. I start doubting the numbers you give me. All right. Before we flip to the back, we have one theorem to go over. So we're going to jump back up here to look at the theorem. If the altitude is drawn from the hypotenuse of a right triangle. Okay, I'm going to pause here for a second because there's a lot of vocabulary words there. A lot of big words. If the altitude is drawn from the hypotenuse. What? 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 Okay, let me show you what that's going to look like. All right, we're going to start with a right triangle. Here's a right triangle. Here is my right angle. Do you see my right angle? All right. Pretend you're sitting here on the corner of this little building and you have a ray gun.
What?
And you're going to shoot it up. Pew! Do you see the side that you ran into? This is the hypotenuse. Okay? That one's the hypotenuse. Always. Always is the hypotenuse. All right? The altitude, hello. The altitude is going to go from a corner. In this case, we're going to pick the corner with the right angle. And it's going to go toward the hypotenuse. So it's going to go the same way that your little laser gun went. And it's going to crash at a right angle. So your figures are going to look like that. Like that. Okay? So all the ones that we're about to do, they're going to look like that. Okay? Whenever this happens, whenever you have a form that looks like that, and bless you, then the two triangles that got formed, this little teeny tiny one and this medium one, those two triangles are similar to each other and the original triangle. All right? Let's do a bunch of examples. Now, the hard part here is going to be the setup. Okay, so I want to spend the rest of our time together. Okay, not all of it, like maybe 20 minutes of it, right? But I want to spend the rest of our time together setting up these problems and doing the cross multiply and divide. Okay? Join me on the back of the paper. Let's start with number 1. We're going to end with number 4 because, oh my God, radicals, right? Like, ah! Okay, number 1. The direction states to the nearest tenth. So whenever we end up with an answer where it's going to be the square root of something, we're going to use our calculator and we're going to make it a decimal. All right. This figure, kind of hard to read, yes? Like, what side is corresponding to what side? Like, we can't tell, right? Because they're all on top of each other. But if I look at the left, that's one little baby triangle. Have you heard of the story Goldilocks and the Three Bears?
Oh, God.
Yes? Where you have this little girl who goes to a house of 3 bears and you have the baby bear with the little tiny stuff and the mama bear with the medium stuff and papa bear with the big stuff. We have baby bear triangle, mama bear triangle, and papa bear triangle. So we're going to draw all those separate and then find the sides that correspond.
Story scarred me
Okay?
for life.
I'm very sorry it scarred you for life. Hopefully it makes this make a little more sense. Okay, so there's
I'm messing around.
there's the baby bear triangle, there's mama bear triangle, and here's papa bear triangle. All right, and all of these are going to be the short side. I'm going to color them all in pink. This will be the medium side. I'm going to color them all in blue. And these will be the long side. I'm going to color them all in green. The hypotenuse is always the long side. And I like that word hypotenuse. It sounds funny. And my favorite color is green, so I'm going to color hypotenuse in green. Because it makes me happy. Okay. I'm going to look at baby bear triangle, this one in here. Now, the hypotenuse is always the longest. So that's always going to be the longest one. And this one looks shorter than these other two, yes? This one looks the shortest. So I'm going to color that one the shortest. At this point, you just have to take your best guess. Okay? And then the medium one. All right, now I can start filling in information. The pink side on the baby triangle is 1. The blue side on the baby triangle is x. And I have absolutely no information about the hypotenuse. I'm now going to look at the mama bear triangle. All right, looking at the mama bear triangle, this is the hypotenuse. And this side looks like it's smaller than this one, so I'm going to color that in as the small side. And then this other side is the medium side. Now look at what happened. Look at the baby triangle. And then imagine it going up and falling over onto its back, onto the blue side. And it created the mama triangle.
That's bad.
Okay?
I'll give you
That's how they're related. You see it? It's always going to happen that way when they're in this format. You see it?
I mean, that's how babies grow up. So they just have to.
No.
Because the way you made it, the way you said it, the baby bear falls and it grows up to become the
So
mom.
we use the mom. Okay, so here's the short side. Here's the medium side. And I have no information on the hypotenuse. All right, let's do the Papa triangle. Yes, I'm taking my time on this on purpose to make sure that it makes sense. Okay? Here's the right angle for the Papa triangle. So this is the hypotenuse. Of the ones that are left, this one is the shorter side. And this one is the medium side. All right, so the only side I have information on is the hypotenuse, and it is 1 plus 3, which is? All right, and now we're going to look at our 3 triangles. They're all similar to each other, so I can write a proportion, which then I can solve, and I'm going to try to find a way to make this proportion work. If I look at this triangle, I have information on the pink and the blue side. Do you notice? And on this one, I have information on the pink and the blue side. So these two are going to be super helpful. Okay, so I'm going to write this in proportion. I'm going to write blue over pink. So here's my proportion setup. Blue, blue, pink, pink. And now I'm going to cross multiply and solve. X times x gives me x times x. X squared. When you do x plus x, it's 2x. X times x is x squared. X squared.
Lot of x's.
And then 1 times 3 is?
3.
How do I undo a square power? Square roots. Thank you. And I want you to write that down up here for me, because that's super important. You're going to need it in Algebra 2. To undo a square power, use a square root. In Algebra 2, you're going to get fancy things, fancy powers, like powers of 3. So to undo a 3 power, use a 3 root. Whatever a 3 root is. They'll teach you that in Algebra 2. But I'm going to give you the concept. Ready? Replace the word square with whatever power you want to use. So to undo a 10 power, use a 10 root. Beautiful. To undo a house power, use a house root. Yeah, it doesn't matter what the thing is, right? To undo a tree power, use a... To undo a tree power, use a tree root. Ah! Look, that was so funny. Okay. Okay, it was stupid and lame. I'm sorry. Okay, so we take the square root of both sides, and we want this to the nearest tenth, and so the square root of 3 is? 1.7, and I heard 2 different people in 2 different areas of the room say that, so it was confirmed. 1.7. There's your final answer. Easy as soon as we got it to proportions, yes? Good. Let's do the setup again on another triangle. I'm going to do the setup here on number 3. Okay, let me zoom out. All right, number 3. Here's our baby triangle. Here's our mama triangle. Here's our papa triangle. I'm going to use the short sides in pink. I'm going to use the medium sides in blue. And the hypotenuse in my favorite color, green. All right, looking at the baby triangle, here's the right angle. Here is the hypotenuse. That information is x. Here's the short side. And here's the medium side. Okay, here's the mama triangle. Use whatever method you need so that you can see the short sides and the long sides and the medium sides, okay? The hypotenuse will always be the longest side in your right triangle. Are we okay on the setup? You feeling better about it? All right, let's write our proportions. All right, this one's a little more challenging because we've got information everywhere. All right, so what I'm going to do is let's look at this one. If I cover this side, I have information about x and then a number. And it's on green and pink. So if I look at just the green and pink here, do I have information about x? No, I have a y and a z, so that's not helpful. What about here? Do I have information about an x? Yes, and it comes with another number. So I'm going to use the baby bear triangle and the papa bear triangle to set my proportion up. And I'm going to use the pink side, the green sides over the pink sides. It is a 1. Sorry, my highlighter was still wet. Better? Thank you. Now we're going to cross multiply and solve. And x is? What was it? 2.8. You got it? Yeah. All right, now we need to do y. Does this triangle have any information about y? No, no. What about this triangle? Yes, and the number, so it's green and blue on this triangle. If I look at green and blue on this triangle, yeah, they're flipped positions, but I have y and I have a number, so I can write my proportions with these two triangles, with the green and the blue. And again, I'm going to choose the colors. I'm going to do green on top and blue on bottom. Okay, so y squared equals 8 times 8 is 64, and I heard that from like 3 different people, thank you. And then so y is the square root of 64, which is 8. Oh, that one gave me a whole number. All right, I need to find z now. Blue and pink. Blue and pink. So I'm going to set up my proportion with blue and with pink. Oh, z squared is 8. I don't need to go to my calculator. I've already got that right here. So I can just copy that. Yes? Feeling okay with this one? You want to see another setup? So, yeah? Okay. Which one do you want to do? We're saving 4 for last, so don't ask for 4 yet. Number 6? I had a call for number 6? Yes? And 5. Okay, so let's do 6 and then we'll come back and we'll do number 5. So you're going to do number 6 first. All right. The hardest part is figuring out our triangles. So we're going to set up our triangles. The small triangle, the medium triangle, the big triangle. Short sides, I'm going to do pink. Medium sides, I'm going to do blue. Hypotenuses. Hypotenusi. I don't know how you say more than one hypotenuse. Maybe because the word rhymes with moose, we should make it do hypotenuse. Like more than one moose is like 10 moose. Maybe? Or it could be like goose. We have one goose and 3 geese, so maybe it's hypotenuse and 3 hypotenuse.
It should be meese. It should be meese.
I don't know. Someone Google that for me after class and tell me tomorrow, okay? All right.
What? It should just be meese.
How do you say more than one hypotenuse? Is it hypotenuse? Hypotenuses? Hypotenuse? I don't know.
It's
Okay.
better for moose if it's multiple. It should be meese.
I agree completely. All right, we're setting up. I'm starting with the small triangle. We're setting these things up. Check it out. Check it out. This is the confusing part. So I want you guys to do this with me. And I would really, really, really love and highly, highly recommend that if you've got some sort of colors, that you go ahead and use colors to help you sort out to make sure that you know where things are going. Someone want some colors? I have some extra colors. Get it? Do you want colors? Colors? No? Okay. All right. Now, on the mama triangle, how did I get 4 for that blue side? What did I do? I subtracted this piece from the whole thing to give me this. Very good. All right. The hard part is done. Is the hard part feeling easy? Oh, good. Oh, good. That means I did this right, guys. I should get a star. All right. I'm going to start with this one just because it seems easy. And I like pink and blue. All right. We're going to do blues on top, pinks on bottom. This one has a Y. Okay. This one has a Y. This one does not have a Y, but this one does. So I'm going to use this triangle and this triangle. Make sure you know how I got that set up. Give me a nod. Great. Cross multiply. Y is about 2.8. It's like the 4th time. They really like this number, don't they? All right. I can do X right here. X looks like it's going to be green and pink. All right, so this one. And which triangle? The mama triangle or the papa triangle? Which one has information with X on it? In the green and the pink sides. The big one. All right, cross multiply. And what is the value of X? 3.5. All right, we only have one more letter to find, and that's the value of Z. I have Z here, the green and the blue. And the big triangle has the green and the blue. So I'm going to make that setup. So green, blue, cross multiply, and solve. .9. Whoops. I was about to put 4.5. Hello, wake up. All right, how are we feeling before we move on? It's easy after you get all the triangles marked down, yes? And that really takes the longest time. Take your time on that. Make sure that that setup is really good and strong. Hi, guys. Over here, please. Make sure that setup is really good and strong because you see how easy it is once you get the setup. Let's do number 4 because, oh my God, there's radicals. It's the same setup. Let's do that setup, okay? All right, so I'm going to have small triangle. I'm going to have medium triangle. I'm going to have big triangle. Small sides, medium sides, hypotenuse, hypotenuses. I don't know. So confusing. All right, looking at the small triangle. Here I go. Please start doing your markings on your paper, figuring out which side goes where. Confirm it off of my work. All right, we're almost done with the setup. We're nearly there. All right. Oh, there's a lot of radicals. Oh, oh goodness. Are you worried? No? Oh, good. Are you worried? Nah. You worried? A little bit? Okay. Now, this X here, I could use this one, the green and the pink. I don't want to use this one for the green and the pink to find the X because it gives me another variable Y. So I want to use this one. Right? So I'm going to set up my proportion with the green and the pink. All right, so I'm looking at these. All right, that looks like it's not helpful at all, right? Because it's this fraction that's made up of square roots. But I have a magic power. And you have this magic power too. The magic power is this. Anytime you have a fraction made up of square roots, you can rewrite it as a square root that has a fraction. Anytime you have a fraction made up of square roots, you can rewrite it as a square root that holds a fraction. Now, this is x over 1. Do I need to keep writing x over 1? No, what could I write? Just x, okay. All right, now if I look inside of this radical, 12 divided by 3 is? 12 divided by 3 is 2? 12 divided by 3 is 4. I know where your brain went. And the square root of 4 is 2, which is where his brain went. His brain was the flash. Easy, yes? All right, so now let's try to find y. I'm going to come back over here. If I grab this one, the blue and the pink, and I grab this one, the blue and the pink, you notice how there's only one variable? It's just the one y. Oh, that means I'm not going to have a y squared at the end. That's going to make that really easy. So let's do this one. A proportion with this blue and this pink side. Okay? I'm going to do it over here. And I'm just going to copy from, I know the work is off screen right now, but trust me that these were the numbers from off screen. Okay. All right, cross multiply. Y equals square root of 3 times the square root of 3. Whenever I have two square roots being multiplied together, I have another magic power, and it lets me rewrite it as a single square root with those things inside, radicands, being multiplied together. The radicands multiplied together is 3 times 3. 3 times 3 is, and the square root of 9 is, and we're done. Not as scary as it looked like, huh? You guys have been wonderful. Thank you so much.